And welcome viewers, friends, and foes to the Daily Space Weather, the main feature of the Smash News Network. Least busted name in news. We're just bringing you the most detailed imagery of the sun and most comprehensive space weather imagery you'll find. Space weather imagery, comprehensive space weather, current events. Will we talk news and politics? Oh my God. Stick around for the rants. Show up for the space weather. We've got lots of coronal mass ejections to cover. There's even a comet showing up on the coronagraphs. Here's the southwestern limb. Let's take a look at the southeastern limb. You can actually see a CME propagating down here. Whoops, some solar plasma leaving the corona. Also, a new sunspot just rose right here. That new group there, that is indeed a sunspot. It's been the flare-producing region of the closest star and the most likely place to see additional, even large solar flares, actually. Somewhat likely to come from that area. Here is the northeastern limb. You will note a CME erupting from this active region right here as well. See that filament? Whoops! Looks like most of it actually collapsed back down toward the chromosphere. So plenty of activity going on here despite a drop in the sunspot number. We've also got new smoothed monthly values, which might surprise you in terms of how much activity we just saw. So, yeah, the sun not shutting down. However, it is exceeding the solar output of solar cycle 24. We'll show you it here in a moment. First, let's take a look at sunspots with the SDO intensity gram. There's yesterday plus today. Again, we will have another named sunspot group right up here. That is beta gamma class sunspot group for sure. So no major downtick in the sunspot number there. In fact, we may even see an uptick depending on how many umbrae are showing up. You can see the magnetic field just rising over the southeastern limb there. And let's take a look at croissant Earth. But first, you're all invited to join us at smashomash.com/smashteam. Are you having the problem that you aren't receiving updates, notifications that we're putting out a new video, things like that? Has that been an issue for you? Well, it's been a common complaint on the channel. Most of our content does appear on YouTube, which is horrendously censored, shadow banned, etc. I don't know what the problem is. It's apparently we don't put up enough propaganda, nonsense, fraud, and disinformation to be promoted by YouTube. So anyway, the point is we put out email alerts when we put these videos out. So if you are a member of the Smash team, even if not, click posts. It'll show you a lot of our content. And if you are a member of the Smash team, log in. Again, we do send out email alerts as well. smashomash.com/smashteam. It's the official subscription services site for the channel and the Smash News Network. Thanks everybody who supported the content. We launched our own subscription services site to replace Patreon, although we still are on Patreon as well. So perhaps find us over there. If you visit the links below the video, one of the ones you'll find is to the Redbubble shop. So check out the merch products as well. Give Smash staff a raise by picking up some merch. Thanks to everybody who's done so. Get something tangible, start a conversation, or amuse your friends and foes because reasons. Congratulate them on surviving a global pandemic so far. Today's featured product is Mensa, which stands for Make Earth Not Suck Again. Why? Because the way we get out of a hole, folks, is to stop digging. You're not going to make Earth great. You're not going to mega the planet. You're not going to make Earth great again, which is a mega idea, by the way. Until you Mensa, you've got to make Earth not suck again before you can attempt to make Earth great. Again, we are also on Patreon if you want to support us there because it's more convenient. Feel free. You'll get more content if you join us on smashomash.com/smashteam. Links below the video and on the homepage at smashomash.com. And welcome to the Daily Renaissance. Let's check out what's going on for volcanoes. So Stromboli's erupting. There's a little ash plume in that top photo. Some lava bombs showing up there. An explosive sequence occurred at Stromboli, not to be confused with Mount Calzone. A beacon exploding on Paramushir Island, producing a 9,000-foot plume of volcanic ash, flight level 090. Please do not attempt to pole vault the caldera. Subanose-jima exploded as well, 5,000-foot ash plume over the Ryukyu Islands. Popocatépetl exploding in central Mexico, flight level 200. It's a 20,000-foot ash plume. Fuego producing a 15,000-foot ash plume over Guatemala as it explodes. And headed to Ecuador, we've still got 2 exploding volcanoes there, Sangre and Revenador, 20,000-foot ash plume and 15,000-foot ash plume respectively, and Sabancaya exploding. 24,000-foot plume of volcanic ash, flight level 240. Is nothing to pole vault. Let's see what's going on in terms of seismicity. There's the past 90 days of seismic activity conveniently amassed by volcano discovery. And let's run up the list. No major quakes over the past 24. We shall report on everything over a 5 magnitude. Some aftershocks occurring there in Iran. A 5.0 in Indonesia coming through last night at 1957 Universal Time. Was that the largest quake of the past 24? I think there might have been a larger one. There's a 5.7, which is made in China. Okay, that quake's made in China. If that was U.S. earthquake, it would probably be like the most amazing, the most spectacular, the most perfect, fantastic earthquake you've ever seen in your life. Okay. As it is, that 5.7 in China came through at 23:49 Universal Time. That is the largest quake of the past 24. A 5.7 in China. Okay, China. Also, southwest of the Ryukyu Islands, we see a 5.2 that came through at 10:25 Universal Time this morning. And let's get back to space. So this is the wavelength we started out with. 304 plus 193 angstroms is great at showing the contrast of solar filaments. That's why we show that composite. We've been starting out our videos because we've had a filament fest going on for a couple of months here. And don't expect that to end anytime soon, because we are a couple of years out from solar maximum. And like I said before, we've surpassed solar cycle 24's numbers in certain categories already, including some smoothed values. So while the 10.7 centimeter radial flux has dropped down to 137 solar flux units, the smooth value of the sunspot number has drastically exceeded solar cycle 24. So there is our 1-year graph from Solon.info. This black line is the radial flux, the red line is the sunspot number, and this pink line is the 30-day Wolf number, the average number of sunspots over a 30-day period. And as you can see here, it exceeded 170. It's 174 is the smoothed 30-day Wolf number. And let's consult the Space Weather Enthusiast dashboard here to compare this to solar cycle 24. So if you look at solar cycle 24, this purple line here is the smoothed value, and the highest it ever got was 110. No, wait, 116. So it did not exceed 120. 174 is way up here. Way up here. Come on, Epic Pen, you can do it. 174 is way up here. So this is the new smooth monthly value for sunspot number, drastically exceeding solar cycle 24. And we can tell by the location of the sunspots and the position of coronal holes that we are nowhere near solar max. So if there are channels out there telling you that we're at solar max, just watch them continue to be wrong. And please note, if they do try to gaslight you in the future about how they were wrong, we've been calling it for years. We state facts on the channel, not a bunch of propagandistic nonsense. Anyway, no solar storms here forecasted by NOAA. There could be some coronal mass ejection material headed our way, though. We'll get to that later in the video. Current state of geomagnetism on planet Earth is a KP1. It's a geomagnetically calm condition. Planetary K index, a measurement of a global geomagnetism. And let's take a look at Earth's magnetic moment from space out to about 12 Earth diameters for the past 4 hours. There it is, croissant Earth, as we say regularly. It's funny because it's real. Yeah, Earth's magnetic moment from space is largely croissant-shaped. That's why it's funny to say Earth is shaped like a croissant, because so many people are out there telling you it's shaped like a pizza. Here's Earth's magnetic moment from the ground. our other space weather modeling framework data grab. This is ground magnetic perturbations, changes to Earth's B field over the past 4 hours. We show it daily on the channel to show people that, hey, look at Earth's magnetic field. It's not going away. It's sticking around. And if you're frightened of Earth's magnetic field, then I don't know. I'm not sure what to tell you. Take a geology course, maybe. MIT offers all of their science courses for free. By the way, you can take them all online. Anyway, let's move on to our real-time solar wind. So we've had a recent uptick here in the solar wind density. It's minor. Solar wind speed's been dropping for the past 24 hours. We've just dropped below 400 kilometers a second here. Current conditions are 396 kilometers per second for the solar wind speed. Solar wind density just over 8 protons per cubic centimeter. The rest of that is fairly unremarkable. Good data there. Next, looking at magnetic data. There are your GOES 16 and GOES 18 magnetometers. A little bit higher lows there in the past couple of days. There's a 7-year chart to put it in a little greater context. And let's take a look at the heliospheric current sheet next. So here's our top view ecliptic plane field plot. And do we see any changes coming to the South Pole current sheet? Not looking like it. It looks like Earth is solidly in a South Pole current sheet depicted here in red. North Pole current sheet here moving to the opposite side of the sun here recently. And let's take a look at the solar line of sight field plot. Here's the sun's B field in blue, solar polar fields in red and green for south and north respectively. So that's what's going on in terms of the solar fields. We're nowhere near solar max, and here's the main reason why we can say so and be confident that we are not blowing smoke up your you-know-what. So we've got South Pole-oriented coronal holes here. We've also got a North Pole-oriented coronal hole down here. North Pole coronal holes rotating out over here. And we've got South Pole magnetism down here. So let's take a look at that from SDO's perspective. We've got south, north. Hang on a minute. Yeah. South, north, north, south. That's the situation. And of course, the polar fields need to migrate all the way to the opposite poles. We've got mixed fields here at the moment. It looks nothing like solar maximum. At solar maximum, you can expect to see no significant magnetism fixated at the poles. We've got magnetism all over the place. So there you go. That's your coronal hole view. It's the most, probably the best insight into where we lie in terms of solar cycle progression. And here is our sunspot portion. So looking at the sunspots next, we'll have at least one new named group here. Sunspot 3207 has already risen. It's already beta gamma class, and it's already the most likely place to see major flares. So the most likely place to see major flares is right about here, where that significant region is rising. It has already raised the background flare profile. We'll show you that in a minute. First, 171 angstroms plus SDO continuum. What's that? It's not close enough. Okay. There's a zoom into a little closer view. Let's subtract the 171 angstroms just to show the sunspots alone. And they've been mostly stable here. This video depicts the past 24 hours. Most of our custom Helio Viewer movies do. Sometimes we make shorter ones at slower speeds for significant events. Let's move to energetic particles. No relativistic particles here showing up in the past 3 days, or indeed the past week. No spikes in the proton flux. Again, a little bit of an uptick there in the X-ray flux. In fact, we've got a little C-class flare happening now. Again, expect the X-ray profile to come up a little bit as that new region in the southeast is showing some activity. So down here is the place to watch for flares. Here's the past 24 hours and 131 plus 171 angstroms. Great at giving us potential field surface source lines toward active regions. Here's a close-up of the northwest. Great imagery there from SDO. Here's the southwest. Little sunspot hanging out down there, also a great filament. Here is the southeast. That new sunspot rising there. We'll show you some high-res imagery of that before we do our meteorology segment. And we may have a new active region or a new sunspot perhaps rising in the northeast as well. We do see some bright region there on the 24-hour HelioViewer imagery. Next, let's take a moment to orient ourselves, but first, there's 94 plus 131 angstroms, the two best wavelengths for viewing solar flares. And again, the most recent flaring has come from this new sunspot. So let's take a look at a star chart here. If you're looking around where the ecliptic meets the horizon here at Lehigh Valley, you might see Castor and Pollux there, as the constellation Cancer is setting. Anyway, let me press now. That's what's going on over Lehigh Valley. If you're up before dawn, you might see Mercury. If you've got low light pollution and a low horizon. So Mercury there rising ahead of the sun as well. Here's a solar system forecast as Mercury is in the process of swinging around to the populated side of the solar system as Earth swings around to the unpopulated side of the solar system. Here's your 1 week forecast for what is going on. There's where things will be in a week. We will have a full moon on the 6th of February. Next, we'll look at coronal mass ejections. And there may be some minor amount of ejecta headed toward Earth. That is yesterday's coronagraph images from George Mason University, the Stereo A Core 2 coronagraph. And I think one of those CMEs may have a tiny earthly component. It's quite diffuse. Don't expect any major fireworks from it. Don't expect to see the aurora in Cuba as a result or anything like that. There's today's coronagraph images, and let's take a look at the view from Stereo A and a little bit more usable data, also Soho Lasco C3, because we've got a comet. Check it out. There's our comet. And it's also showing up in the Stereo A imagery. Now, we paused this at 1:53 Universal Time because this CME that's happening here, this may have an earthly component to it. So if we stop it right there, let's see, let's stop it right there at 2:53, 1 hour later. For some reason, we've got limited data here, so we do see a halo-like projection happening there, so there may be a small earthly component. Most of that CME will miss Earth to the southwest. Let's let these play through here. We've got a limited number of frames on Soho Lasco C3. So keep in mind, those are not time synced. Consult the time and date stamps at the bottom. And you'll see that comet showing up on the imagery on the left, the Stereo A coronagraph, right at the end. You'll see that comet coming into view there. And there it goes. So fantastic imagery here. You might find some missing data around the internet if you look for this today. So we showed it to you right here. That's what's going on. And let's take a look at filaments. So filaments are next, and you'll see this filament, interestingly, it like spins in a spiral like this, and then it kind of collapses. Watch. Great imagery there from Cerro Tololo, Chile. Zoom in a little bit closer to get the maximum resolution view. And we should probably name this filament after a living person. So this filament right here brings us to our next segment, which is on Twitter. We've started a new hashtag. Name that filament. So hit us up over there. You can't name filaments in the YouTube comments or the BitChute comments. You got to join us on Twitter. So if you don't have a Twitter account, create one. Go follow us over there on Twitter. There's all kinds of information besides space weather stuff. If you enjoy the content on YouTube, thanks for tolerating the pathetic censorship. And please press like, subscribe, share, etc. Leave a comment And if you're an influencer, drop us a line. We'll be more than happy to appear on your channel and talk about facts. Have you heard Journey to the Center of the Hearse yet? Yeah, that's a real thing. The 12 Days of Smashmas are one of the many playlists you can find on the channel. Also playlists about things like product reviews. There are even some ownage food and drink, terms defined, and lots more. So visit the homepage, help us out with clicks. If you're unwilling to open your cobweb-encrusted wallet and send us a few bucks per month on Patreon or via the Smash Team site, all our links there on the homepage, and welcome to Neo-Renaissance. Smashomash.com if you want to hear about what causes the solar cycles. Become a gold member at the Smash Team. We've already divulged it, and thanks for leaving a comment. Or leaving a few comments, Stevo8778. Smashomash.com is the homepage. And here's one last 24-hour video for you here from SDO. We like the 335 plus 171 angstroms as it provides great definition to the very bumpy solar corona. So that's the last 24 hours. How about the last 2.5 hours here from the GOES 18 SUVI? Still some major activity going on up here. I believe that is the Dick Van Dyke filament, and it is not done yet. By the way, there was some amazing imagery of that yesterday. If you didn't follow us on Twitch, the Twitch channel featured some incredible coronal mass ejections. Twitch.tv/Smashomash is actually where this video was originally live streamed. We like the live streaming format because, well, it creates tension that would otherwise not be created. So last night when we went to bed, this is what we were seeing. Major CMEs happening down there. And that's the one that's still in the process of exiting the corona now. So the Twitch channel, we typically stream live all day. Solar imagery. If you haven't checked it out, check it out. And it's time to get to our bonus features segment. So bonus features here. We will start out with charging hazards. Yes, charging hazards for your favorite satellites. What's going on with them? Well, they've got smooth sailing. There aren't any charging hazards here at the moment. Continuing on to our GOES electron flux. Now, the GOES 16 and GOES 18, they measure that electron flux from their geosynchronous orbits. They're located at about 22,000 miles of altitude, but they measure it at about 300 kilometers of altitude, where the F layer of the ionosphere is located. They use radiography to do that. And we're just in a normal operating range here of electron flux. There is the forecast model. No arguments from me there. That's NOAA's electron flux forecast. Here's the one-year graph to put that in context. Climbing back into normal levels here. And here is the vibrational frequency of the F layer. The F layer of the ionosphere. 300 kilometers of altitude is one slice of the upper thermosphere. This is what's going on in vibrational frequency. And we're seeing evidence now that the South Atlantic anomaly, get this, has moved back over the South American continent. So if that's not weird enough, it moved from the South Atlantic, somewhere in here, into the South Pacific after moving onto the South American continent. So it was down here for a solid couple of weeks. Then it moved way up here, and now it seems to have moved back to South America again. If you can't see it in that imagery, the anomalygram imagery will be much more clear for you. So after that plays through one more time, you can clearly see the big striations in the ionosphere happening there. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. And it looks like the South Atlantic anomaly is now back over the South American continent, right where my mouse is. You can clearly see that big variation in high to low frequency anomaly there. That's showing anomaly in megahertz from a 30-day median. So once again, the South Atlantic anomaly has moved from the South Atlantic to the South American continent, to the South Pacific, back up here toward the equator, and then back to the South American continent. So I find that interesting. And if huge structures in the Earth are responsible for generating Earth's magnetic field, how was that massive movement not accompanied by massive earthquakes in the region? Anyway, let us know in the comments what you think. And if you've got ideas as to how Earth's magnetic dynamo is generated, let us know about that in the comments also, or perhaps post at smashomash.com/forum. It's entirely free, smashomash.com/forum. You can talk about whatever you want there. We are free speech purists, and anything that's legal any legal speech will be encouraged, although you might be made fun of if you say something idiotic. Because remember, while ignorance is the key to all knowledge, there are no stupid questions, although there are certainly stupid people. Anyway, there's the latest image. That's 12 o'clock Universal Time, Anomalygram, and the Ionogram. South Atlantic anomaly back over the South American continent. I don't know if anybody else saw it because barely anybody watches the channel. Next, looking at the total electron content forecast, it'll show the free electrons between your GPS satellite and your handset. Those free electrons can cause massive signal diffraction. And here's an animation of the total electron content. So it's getting much less anomalous here, although we are still seeing anomalously low electron contents over the Northern Caribbean and Southern South America. So I'm just going to put dots on all the anomalies. We've got a dot right here. We've got a dot down here. Those are low frequency anomalies. We've also got low frequency anomalies in these areas. So lots of oddities there with the locations of the free electrons. Keep in mind that is the total electron content, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Your GPS signal must go through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere to get to your handset. And there could be a lot of electrons in between. They typically focus around the equator at noon, and we see this getting much less anomalous than it's been for the past about 6 weeks. It was very odd. There were huge GPS errors, and they will still continue, but it's a lot more organized than it's been. As the electron flux rises, we get more organized electrons. It's just a fact. We've covered it for years on the channel, and it does have predictive value, unlike a lot of nonsense you might see about space weather on YouTube. Anyway, here is our latest colorized magnetogram and SDO intensitygram. Let's take a look at this new sunspot. It's where the flares have been coming from, so there are the magnetic fields, and there is the sunspot itself. It's got a leading South Pole umbra and a trailing North Pole umbra. Or does it? I'm not so sure. That might be an alpha class sunspot, but I suspect there are some opposite polarity umbra behind it because it's been producing some flares. So the likelihood of it being alpha class is kind of low. Anyway, there's your rock back to show you all the sunspot groups. May have a little dip in the sunspot number, may have a rise in the sunspot number, but it should be fairly flat here. We don't expect to see a major dip, and it's time to move to the realm of meteorology. So I started doing space weather because I realized that there is a niche. There is a hole in the space weather coverage, especially in terms of like YouTube channels that cover it. There's a lot of crap and nonsense on YouTube about space weather. But I realized in 1995 that there was a problem with cosmology, and the problem is derived from heliophysics. So I knew I had to come back. I almost pursued a degree in stellar cosmology, but I just didn't because it would have required me to go to California or something like that because there was no degree. I would have had to have basically created my own degree in stellar cosmology to have majored in it where I was located, which was Kutztown University, Pennsylvania. So yeah. Anyway, meteorology is too easy, so we throw it in, and we're going to have a lot of news stories about how cold it is. Thank your lucky stars that you aren't located in Siberia, where it's negative 53.8 degrees in some locations. So that's the coldest part of the whole planet, actually. It's even colder than Greenland, I think. All right, negative 54 degrees there in Greenland. Yowzers. So anyway, it's comparably cold to Greenland. And the U.S., yeah, it's getting a little bit on the cool side in the U.S. as well. We'll show you a temperature forecast here a little bit later in the meteorology segment. And let's take a look at wind. So there are a lot of blowhards on YouTube also that talk about weather that don't understand atmospheric physics. They rely on models, and they have no idea what they're talking about. So that's yet another reason why we cover weather. We show accurate forecasts, not nonsensical, alarmist garbage. Anyway, let's get rid of that. There are the surface winds of the eastern world. Here are the jet streams of the eastern world. And if you had to pick only one data set to forecast global weather patterns, the jet stream would be the one I would pick. What about you? Let us know in the comments what you think. There are the jet streams of the west. And here are the surface winds of the west. Strong low pressure there, south of Iceland. Here are the surface winds of the central world, like Europe, Africa, and the Middle East. And these are the jet streams of our lives. Continuing on, here is our clouds and fog view for the Americas. It's shortwave radiation over Crescent Earth. And let's take a look at our weather.gov map. We'll scroll down to show the key. Lots of cold weather warnings there and lots of wind warnings. Also winter storm warnings on Mauna Loa and Mauna Kea. Yeah. Anyway, we scrolled down to show you the key briefly. If your location is lit, click your location at weather.gov. Again, lots of cold weather warnings showing up. So here's your temperature forecast. Yeah, temperature in degrees Fahrenheit based on the GFS model. So that's surface temperature at 2 meters for the next 72 hours based on the GFS. And you can see we will see some temperatures here at over 24 degrees below zero in portions of the U.S., especially places like Minnesota, North Dakota, Wisconsin, and the Upper Peninsula. That's your temperature forecast. Here is your pressure and precipitation forecast. We'll have some icing happening, as well as some rainfall. That's pressure and precipitation based on the same model, the GFS, for the next 72 hours. And here is our total accumulated precipitation forecast in inches. Again, the same model, GFS, same time frame, 72 hours. And since some of that precipitation will fall in the form of snow, let's include that as well. Positive snow depth change, GFS 72-hour forecast. All that hot air coming out of Colorado is not going to prevent a bunch of snow from showing up. Next, we'll show the Euro model. So here's the GFS forecast for snow over the next 3 days. Expecting some heavy snow there in Mexico, deep into Mexico, as central Canadian air drives its way quite far south towards Central America. That's the GFS model for the next 3 days. There is the Euro model for the next 3 days, also forecasting a significant snowstorm in Mexico. Not the most common situation. GFS, Euro, GFS, Euro, and it's time to move on to our lightning mapper. So we did have some lightning here around the Gulf Coast in the past about 10 hours. And do we have any active cells at the moment? We may. We may indeed. Maybe not. Last lightning here to have struck was south of Montgomery, Alabama. Current situation is calm as far as lightning, although the eastern Mediterranean seeing some. We've got some Israeli lightning. And oh my God, is this a Zionist channel? Oh my God, I've got to unsubscribe. He said the word Israel and didn't say something negative about the folks that live there or Zionism or whatever. So here's our U.S. Doppler radar map, and we're going to show a close-up for once here of Alaska. So we've got some significant precipitation happening there. We'll zoom out a little bit to show the illusions, and then we'll get rid of that nonsense, because if you click on the map, you get this stuff, and we don't want that. We'll also show Hawaii, as there is quite a bit of precipitation happening there. Check it out. There is the Hawaiian archipelago. And it's not animated because reasons. I pressed refresh and it didn't animate because reasons. Anyway, that is radar.weather.gov, by the way. You can thank your taxpayer dollars for that. Let's press refresh again to see if it'll animate. Oh, I got to press the play button. There we go. Sweet. Some snow falling around the Great Lakes. and around the hot air center of the world, Denver, Colorado. The capital of hot air, Denver. Anyway, here is your shortwave radiation show on clouds and fog. And here is your water vapor map. Looks like clear skies over most of Oklahoma and the Texas stovepipe. Anyway, this is your recap to close out the video. U.S. Doppler radar for the lower 48 states of AUSA, the allegedly United States of America. Shortwave radiation, it shows clouds and fog. It's dark over half of the country. But the 3.9 nanometer radiation satellite doesn't miss a beat. And there is our water vapor map. Hopefully that clears things up. Hopefully we've cleared up all kinds of facts about all kinds of nonsense that you might be taking in when it comes to the realm of space weather, geophysics, etc. If you're one of those channels that spouts nonsense, you know who you are. You know who you are. Accountability always comes. So wait for that. We'll enjoy it here at the Smash News Network, least busted name in news, because accountability is going to come for us too. Anyway, in the meantime, may that solar wind be at your back. Facts stated in this video suppressed by big tech criminal organizations for your improvement of your online experience. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.